So let's see what we can do to improve our ability to perform well when we have training or competition in the heat. So the word acclimatization or acclimation refers to the series of adaptations due to exposure to the heat. Even though both of those terms have been used interchangeably, there is a difference in the definition of those two words. So acclimation refers to more of the natural adaptations to the environment, to a hot environment, while acclimatization refers to responses to an experimental setting or a non-natural and artificial environment, like, for example, exposure to the heat in a heat chamber in order to adapt to a warm temperature. So let me show you some data out of some of the classic first studies in the topic of heat acclimatization. So let me explain a little bit, because those diagrams at first they look a little bit confusing. So first of all, we have heart rate, rectal temperature, and mean skin temperature. And on the y-axis, on the x-axis, we have the control, the acclimatization period, and again control, cool control at the end. So each one of those lines, they show the beginning at the end of a training session, from the beginning to the end. For example, the heart rate from the beginning to the end on a separate day, and here is on a third day. And here during the period of acclimation, we have the from beginning to the end of the workout, from the beginning to the end, etc. So what you can see here is that if you do this type of exercise in a cool control environment day after day, you don't see any significant trends as far as rectal temperature differences from day to day at the end of the workout. If you pay attention here during the acclimation, you see that core temperature increases, first of all, much higher than when the same workout took place in a cool environment. And as you can see, from day to day, there is a progressive decrease in the maximal rectal temperature, for example, here in this data, and maximum heart rate in the upper data. So this decline in the maximum heart rate and in the maximum rectal temperature indicates that the body is adapting as a response to the repeated exposure to a hot exercise condition. Let me share some data with you as far as adaptations to a hot environment in response to heat acclimation protocol. So here we have data on rectal temperature. This is from baseline to the end of the 4-hour period. And we have a progressive increase in core temperature when the subjects were unacclimated. And this is the same data that we have for the same people after the subjects were acclimated. So you can definitely see that for the same kind of activity, core temperature was significantly lower at the same time point, so significantly lower. If you take any time point, for example, here we have under 38 degrees Celsius versus here we are almost 39 degrees. Final temperature after heat adaptation, a little bit over 38 degrees versus 39.5 degrees Celsius. Let's see what happened in the heart rate responses. Let's pay attention to this diagram first. Heart rate responses before acclimation, heart rate responses after acclimation, sweat rate. We have here sweat rate before acclimation and sweat rate after acclimation. So one interesting thing about sweat rate is that as a response to heat acclimation, you have increase in your ability to sweat. So you produce more sweat, and as a response to the higher sweat rate, you have the ability to dissipate more heat. one very interesting adaptations for repeated exposure in the heat is that we have significantly lower heart rate responses. And these lower heart rate responses have been associated to one of the major adaptations to repeated heat exposure, which is expansion in plasma volume. So for some reason, our body, when we get repeatedly exposed to a heat during exercise, expands plasma volume. And as we can see in this diagram, we see the greater the increase in plasma volume, the greater the reduction in heart rate as a response to heat acclimation. So expanding plasma volume seems to be a very beneficial adaptation that we see it in the cardiovascular stress. So a little bit more on the sweat adaptations. Here we have the relationship between rectal temperature, which is on the x-axis, and sweat rate. And we can see, well, the rectal temperature increases, so we have a higher sweat rate. We also see that it takes some increase in rectal temperature before we start seeing increase in sweat rate. So the interesting finding is that after acclimation, we see two major adaptations. One of them, we have decrease on the threshold for the onset of sweating. So sweating takes place at a lower internal temperature. It doesn't, your body doesn't have to wait till it reaches higher temperature to start sweating. And the second one, of course, is that, you can see that in a certain temperature, let's say, for example, 38.5 degrees Celsius, you're approximately 320 milliliter per hour, while after acclimation, the same temperature will lead to almost double sweat rate. So this is one of the major adaptations. Another thing which is very interesting is we see the relationship between sweat rate and sweat sodium concentration. We have said that sweat sodium is relatively low or lower than the sodium concentration in the interstitial fluids and in the plasma, which is around 140 milliequivalent per liter. Here you see the higher the sweat rate, we have higher sodium adaptation. The interesting here is this, that as a response to acclimation, you see that for any given sweat rate, we have significantly lower sweat concentration. So what the body does when you get heat acclimatized, your body becomes more efficient and it wastes less sodium for any given sweat rate. So that theoretically could be very useful in conserving more sodium, maintaining better fluid balance, and avoiding a situation where sodium levels decrease significantly all the way to the levels of hyponatremia that we will discuss later on in the semester. So to summarize all the things that we discussed, you can see here in a diagram the different adaptations from increase in plasma volume, decrease in heart rate, exercise capacity, thermal comfort, skin temperature, core temperature, and sweating rate, that you see all the positive adaptations. And those adaptations, we can see on the x-axis how quickly those appear. What is really interesting is that you see that majority of those adaptations take place within the first few days. So within 6 days, you have most of those adaptations. You can see sweating being one of those that takes a little bit, a few more days. But typically we say that if you want to have full heat acclimation and all the benefits of the adaptation to the heat exposure, 2 weeks is typically required to reach the optimal level, especially if you have very important competition like Olympic Games, World Championships, and stuff like that. So now let's fairly quickly discuss this situation where this is an alternative way on how to achieve adaptations to the heat without really having to be heavily exposed to the heat. This is an interesting study from a colleague of mine from Neil Wall's laboratory. Actually, this is when Neil was in Bangor University. I'm going to jump quickly to the protocol. So this is what he did. He did regular training for 6 days. And at the end of the training that you can see here, he either do 40 minutes control water temperature immersion, and that was the control leg of the experiment, or the hot water immersion post-exercise. So after they finished the regular training in 18 degrees Celsius, the athletes did a 40 degrees C hot water immersion, hot tub after a difficult training. So also you very quickly their findings. Here we have some of the description and the type of temperatures that they reach in how many days. But I think the important message is here. The rectal temperature declines significantly both in a cool environment and in a hot environment. And I think the most important thing, this is what everybody wants to know, do you have a benefit in performance? And the question is, yes, you have a benefit in performance. Obviously, when you exercise in a hot environment. And actually, if you pay close attention, you see that there might be a small but significant increase in performance, even when after heat acclimation, even when you exercise in a relatively cool environment. And if you read one of the papers that I gave in Canvas Cell, you will see that there is an entire study that they examine the impact of heat acclimatization in exercise performance, not in a hot environment, but rather in a cool environment. And since some of the adaptation seems to have a beneficial effect, for example, in the cardiovascular system by expanding plasma volume, they found out that mainly this increase in plasma volume seems to drive additional improvement to performance, well beyond and above to what benefit you have as a response to just regular training, even when you compete in a cool environment. So start thinking about heat adaptations and heat acclimatization, even if you're not planning to compete in a hot environment. Thanks for paying attention, and let me know if you have any questions.